So Korg has come out with a new vacuum tube used for preamplifiers, and it uses phosphor technology, much like what we have inside this clock display that I bought. And so what they've got in their NuTube is they've got kind of an anode, and then they have a screen, and then they have a heated wire, right, for a cathode, right? And then that heated wire goes to ground and about 0.7 volts, I think. Anyways, really all you need to do is heat that wire up, and then you get a flow of current through here. And that flow of current is, you pass an audio signal into it that's biased, and that makes that flow of current through here attenuate according to the audio signal coming in. And very much like a vacuum tube or a MOSFET. And so what I'm going to try to do is I'm going to try to experiment with this guy, which is very similar. It's got a screen in front of a phosphor base and heater wires here. And so what I'm going to do is I'm going to try to turn this guy into a little preamp using the same kind of behavior. So here's a circuit for a NuTube. And I got it from www.pmillet.com. He uses buffers here, and we're going to experiment with that too for the input. And then here you can see the input comes through a coupling capacitor and is biased by these two resistors here, and then comes into a buffer, another coupling cap, and then another biasing resistor here, and then it goes to the grid, and then you've got the heater here, and the heater comes down here into a 3-volt voltage regulator, and that's what heats that heater up and acts as the cathode. And so what first thing I'm going to do is I'm just trying to get this old tube, get it so that I can get these cathode wires heated, and then I'm going to experiment with tying all the legs of the segments together, and then I'm going to tie the grid screen, or the screens together as well, the blocking screens together as well, and see if I can turn this into an amp. And so that I think what's happening with this is that you're enabling different segment values, and then you're turning the screens on and off to, if this is obviously from a clock, so when you're operating as a clock, you're using the screens to turn different digits on and off, and then all the different segment parts are tied together through these connectors here. So I'm just going to tie all the segments together, and I'm going to tie all the screens together, and I'm going to use the screens to again act as a block for the passage of current through here, or however you want to think about it, and just see if that works. I think it'll be a fun experiment. Okay, so I've just been kind of looking through the glass trying to figure out these pinouts, and 1 and 22 are going to the cathode heaters, and then 4, 10, 12, 15, and 19 are going to the screens. And then it looks like other than 2, which seems to kind of go and touch the glass here, It looks like the other pins are probably going to be the segments, but I'll see if I can see any wiring in there, but I don't think I can. Okay, so I've got my little heater circuit. I'm always going to draw it like that, but it's really just those straight wires. And I'm going to use a 3.3 volt regulator. And a couple of filter caps. And plus 12 and ground. That should give us 3.3 volts, and then I'm going to experiment with this resistor here to give me, if I remember how these things work, they should just be lightly glowing. And like if you look at clocks in the dark, you might be able to see them. If they're orange at all, then it's too much. Anyways, so I'm going to mess around with that. Okay, so I'm just going to keep messing around, and I'm going to turn up the current. Like I said, I found somebody who said it should be 70 milliamps. I'm just going to be keeping an eye on the wires to make sure they're not glowing too red. Okay, that looks perfect because I slowly turned it up to 70 milliamps, and at 70 milliamps, if I shut all the lights off, I can see it just faintly glowing red, and I think that's where I want to be. So I'm going to take this circuit and solder it on the back of here, and that's going to be my heater circuit. Okay, so then with the 4.7 ohm resistor, we seem to be right where we need to be. Here I've got it all wired up on the circuit board, and here you can see the elements glowing red. But one thing I thought was kind of funny is that when I put my fingers across it, you can kind of see the elements lighting up a little bit. Interesting. Okay. And there's the circuit. I just put the voltage regulator over here. I'm going to have to put a heat sink on it because it's getting warm. The resistor might be a little small. I don't know. First step. Okay, so after much soldering, I brought together all the grids and I brought together all the segments. So again, we've got our anode, we've got our grid, and we've got our cathode. And our cathode is at 3 volts. And so what we want is what's called a grid stopper resistor. We're going to put that, but we're going to put it to 3 volts. And what that's going to do is that's going to bring it level with the cathode. And so that then when a signal comes in like this, it's going to accelerate the electrons, and when it comes like this, it's going to decelerate them because it's going to drop below the potential here. We're just going to put a capacitor here and just a coupling capacitor, And then again we're going to put a resistor. So this is very similar, or it's exactly the same as a tube preamplifier circuit on a triode. And so then this is where we're going to get our output. This is where our input's going to go. So the first thing I'm going to work on is this circuit right here. Alright, so we have a capacitor here, and that leads to here where we've got our grid stopper resistor going to 3 volts, and then we have our connection to the grid connected right here. That's going through there. It's shielded, but I don't have that grounded yet. And then up here we have from 12 volts going across this variable resistor, and then that's going right to the digits themselves, which is the anode. And then I left it as a potentiometer so we can mess around with it. And yeah, so we should be ready to roll here. So you can see, I turned down the lights a little bit, and you can see that the lights are just dimly lit. This digit seems to be lit more than the others. And so that's a good sign, because we want it to kind of not be fully lit. I think this is not lit enough, but I'm going to mess with this potentiometer and see if I can put a little more voltage onto the grid. I'm sorry, the anode. Okay, so here's I got the whole thing working. So here I'm pumping in a 440 hertz signal, and you can see some of the digits light. Not all of them light. I'm not putting enough voltage into it, but I don't want to put too much more because it'll burn up my 3 volt power regulator. So when I'm looking at the scope, this is my input signal, and we're set, both channels are 500 millivolts per division, and you can see that the output signal is quite a bit bigger than the input signal. And so I've got about, so right now I'm putting through a 440 hertz signal through the display and display amp, and here we've got an input signal of 100 or 460 millivolts and an output of 2.24 volts, and that's a gain of about 5, which is, I think, pretty good. And here, let me put it up to kilohertz. Five kilohertz. And we're seeing our signal kind of drop down there, so I don't know, that might be my coupling capacitors. Probably is. Although it's starting to distort too, so that's kind of interesting. So I'm just looking at the distortion at 5 kilohertz. And that's our fundamental. And that's the doubling. So this might give kind of a nice tone, I don't know. But it's at the higher frequencies too. Yeah, that's out of our audible range there. Let me try 2000 hertz. Yeah, we're still getting distortion there as well. Huh, interesting. Yeah, those are nice overtones. So here I have the voltage up around 20 volts, and we're not seeing much distortion. But then when I bring the voltage down to, there's about 15, 12, we're getting all kinds of crazy, yeah, and there we're seeing a lot of distortion. So let's see, when I keep it up there, I'm going to try it at 5 kilohertz. Huh. Yeah, that's interesting. Yeah, interesting. I don't know why. We're just seeing an overtone above. I bet. Let me try putting the voltage up a little bit and see if that diminishes. Yeah, a little bit, but I'm going to burn up my voltage regulator. So here's the final circuit. I think I ended up with 100K here and 320 on this potentiometer here, and that seems to work. I did put a buffer here, experimented with that. That didn't seem to make much difference. I got a output coupling capacitor and input coupling capacitor, and yeah. And so next we'll look at what the display itself actually looks like, which is kind of interesting. So here we're running at we've got 440 hertz going through. I'm at about 12 volts for the voltage coming in, and I'm going to turn up the voltage. There we can see our display. It's interesting to me that not all the digits are lighting up. So here I set the frequency to 1 hertz, so you can see the blinking, the fading in and out as that audio signal is coming into the grid. I'm going to turn up the amplitude. So that's 1 volt peak to peak. That's 3 volts peak to peak. So here I've turned the input amplitude up to 2.9 volts peak to peak. Actually, it's showing a little more than that. And our output peak to peak then is 9 volts. The input voltage is 30 volts right now. I should check my regulator to see that it's not. That's all right. And 440 hertz. It's kind of interesting. We're distorting like crazy, like you would expect. So now I'm going to turn my input down. Yeah, it's interesting. We start getting distortion right at about 1 volt. Well, that'd be perfect for a guitar. Anyways, that was my demo. I wanted to just see if I could make my own homemade NuTube, and I think I'll cut it off at that. And thanks for watching, and please subscribe. Thank you.